The Love Shack. All right.
Let's go!
Today we are talking about Beer's Law. Beer's Law. I have your period mostly graded, except for obviously people who have not taken the test yet. And they've been good. The test has been good so far.
Okay, what would you like to guess the average is?
I'll get you more paper at the end of the year.
I would say the average of this test will probably end up being 83, maybe?
Okay.
Okay, that's
I'm guessing. I don't know. That might be low. I'm not sure.
all day today.
No.
Oh dear.
We're going to do this. This will take like 15 minutes, and we're going to have a FET. So,
At least it's on hope.
it's easy.
At least
It's
on
easy.
hope.
So this is an intro. It's like a little online like simulation thing.
No, I hate you.
Aren't FET? I think FETs are better than Gizmo.
They are.
So.
They're better than Pogles.
Anyways, so I'm gonna explain this to you today, and then we're gonna do a lab on this tomorrow, and that'll be the rest of the week. And then Monday, we shall start buffers, chapters 14 and 15, all of Unit 8. And if you look, Unit 8 actually is a little shorter, but you have to understand Unit 7 to do Unit 8. So that's the plan. All right. So this is called the Beer-Lambert Law. You've heard of this before. The Beer-Lambert Law, two people, is used to relate concentrations. Are you okay with me using brackets for concentrations? Concentrations of colored solutions. Concentrations of colored solutions to the amount of visible light, to the amount of visible light they absorb. To the amount of visible light that they absorb. So, in lab tomorrow, we're going to be using a colorimeter. And I have a colorimeter. And we're going to be seeing how much light solutions absorb. So, the amount of absorbance is found using the following equation. So the equation is A is absorbance is equal to epsilon BC. So that's not a regular E, that's like a fancy squiggly E.
It's like the Euro E or the.
Yeah, kind of. So this is where A is absorbance. A is absorbance.
Oh, it's not.
E is molar absorptivity. Absorptivity, it is a word. Absorptivity, which is, this is a constant.
Wait, what's A then?
Absorbance. This is a constant depending on what's being tested.
So I just written E.
I don't care.
You see,
C is going to be what you would expect. It's concentration. C is concentration. And B is path length. And what do I mean by path length? Well, we're going to be using cuvettes tomorrow, these little square cuvettes. One side, well, opposite sides, it's a square. Opposite sides, one side is clear on opposite sides and one side's lined. You only ever touch the lined side. Because if you touch the clear side where the light goes through, your fingerprints are going to get on there and they mess with the absorption. So,
C is concentration of.
C is concentration, just the molarity, the concentration. And the path length is the length of the vessel, I guess I could say. Length of the vessel the sample's in. So for tomorrow, it's going to be like 1 centimeter. And that'll be something that I'll give you in lab.
Does it have to be in centimeters or meters or like?
It's usually centimeters. It's usually centimeters. But the unit's not super important. As long as you're consistent through the lab, it's good. So when absorbance measurements are made at a fixed wavelength, in a cell with a constant path length, comma, A is directly proportional to C. Yes, A is directly proportional to C. So tomorrow, you're going to be getting data, and you're going to be building a graph of absorption versus concentration. Then, based on that graph, you will then be able to figure out the slope of the graph, y equals mx plus b, and you're going to be able to tell me what is the concentration of glacial freeze Gatorade.
What is a wavelength in a cell?
In a cell with a constant path length, A is directly proportional to C. So, if a solution follows Beer's law, which is Beer-Lambert, but we just say Beer's law. If a solution follows Beer's law, a plot of A versus concentration gives a straight line. It should give a straight line. So here's my graph, here's A, here's concentration. This should be a direct relationship. It should be a direct relationship. So if a solution follows Beer's law, a plot of A versus concentration should give a straight line, and it should look just like that. It should be a direct relationship. Let me know when you're caught up because I got to flip my page.
How do you vary the how are we going to vary the concentration?
So there will be a stock solution. So tomorrow we're looking at, what's that?
You're just going to dilute it.
I already diluted it for you, yeah. So it's essentially just a dilution where we're always keeping 10 milliliters consistent. So kind of like our rate law, but different. This has nothing to do with rate laws.
Then this is just basically, like I don't even know, but is the sensor just kind of measuring how much reflects and how much absorbs?
Exactly. So the sensor is measuring how much light is absorbed by the dye in each dilution. That's what the sensor's measuring. Let me know when I can flip.
What?
Good? Okay, we're almost done. So, this plot can then be used, once we have that, to determine the exact color of a substance.
The plot meaning like the graph.
Correct. Of a substance. So this means the color observed is the wavelength that is not absorbed. You have to think about that, right? So if I am looking at something blue, right?
Oh yeah.
What color am I going to want to send through it? You're going to want to send red through it, right? Because I want to have something that's not being
Because
absorbed.
then it would just like reflect, right?
Correct.
Okay.
So you have to think of the color wheel, and you want to send the opposite color through. You want to send the opposite color
For the
through.
best rate though.
For the best, you got it. So it's the color not absorbed. That's really important. So if a sample
Is that color observed?
absorbed, the color observed is the wavelength that is not absorbed.
That's
So if a sample absorbs orange, if a sample absorbs orange, it will look blue. It'll look blue. So you have to think about your colors, and you have to do the complementary color, the one that you're going to send through. And what we're going to do tomorrow is we're going to use dilutions. We're going to use dilutions to compare concentrations to absorbance. That is Beer's Law. That's Beer's Law. So, you guys have a little FET to do. You can work together on this, or by yourself. I'd work together. So, finish this, and this will be it for the day. So, it's a pretty easy day. So, do this FET. This will get you ready for tomorrow's lab.
Is there a data table for the lab?
Yes, I will post the data table for the lab soon.